Yeah, all of you can able to see the screen, right?
Yes, yes, we can.
Yeah. So yes, I'm Supriya Umar-Setti. Today I'm going to explain you all about MSIE flow. So by the end of this session, you will get to know about MSIE and what are the benefits of MSIE and how to run MSIE and what are the drawbacks of traditional MSIE. So my main agenda is so what is how we will run or simulate using traditional flow, and what are the different challenges we will face while we are simulating any design or TP using a traditional flow, and introduction to MSIE flow, and benefits of MSIE over traditional flow, and statics of traditional simulation versus simulation using MSIE. So how to run MSI flow with a live project example. So here in a traditional flow, if you want to run any SV file, you have to follow few steps that is like a compilation, elaboration and simulation. These are the common steps for every small changes also. If you are doing any small changes, you have to recompile it, re-elaborate it, and again you have to simulate it. So the compilation, which involves checking the syntax errors and the schematics and generating intermediate representation of the design and test bench. And elaboration involves hierarchical expansion of the design. It resolves the reference to the modules, instance, variables, tasks, and functions across the design hierarchy. And in the during elaboration, the simulator rebuilds the internal representation of the entire design hierarchy, and simulation, which involves the initialization and execution of the design. So below is the pictorial representation of the normal SV file or any design or test bench. So using a traditional flow, you can say here I have taken three different test scenarios. For each test scenario, you have to you have to compile it, and then elaboration step is going on. After that, you have to simulate it. Same steps involves in three different test scenarios. And what are the challenges that we face in a traditional flow means, if you're taking any SoC means which involves a different processors or memory units, like on or off chip memories, timing sources like oscillators. So these were there inside the SoC, and as the complexity of SoC is increases, we have to decrease the size of the SoC. So as the number of blocks increases, the complexity of the also increases. So as the complexity increases, automatically elaboration time also increases. So here we are introducing MSIE technology, Cadence MSIE flow, which is a multi-snapshot incremental elaboration flow, which reduces the time of elaboration. So here we can, as I told you already, so it's from the Cadence. So Cadence multi-snapshot incremental elaboration. This is general name of Cadence Exilium incremental elaboration technology, which allows a set of pre-elaborated primary snapshot to combine with the incremental portion of the environment. So here we have two different runs, which is like a primary run and a secondary run. Uh, for example, if you are taking any design, and if you want to modify it, so in traditional flow, what we have to do is like, after modifying, you have to recompile it and re-elaborate it, and then we will go with the simulation step. So here we are introducing MSIE. So MSIE, what it will do is like primary run, which is a constant, and a secondary run, which whatever you have changed, the changed part only it will compile and elaborate. So these primary and secondary run will combine, and again we will do simulation. So like that, we can reduce the elaboration time. So if you are this is like a capability enables faster elaboration of the design and verification environment in many common situations, as including following. So the changes are local to the test bench or a verification environment, but not in the design. and linking different test bench hierarchies to the design that are already elaborated ones, and changes local to the design, and when the rest of the verification environment is unchanged, like from the designer perspective, and this is the most useful feature during the debugging phase, as it enables very fast turnaround time after a small modifications. So it significantly boosts the productivity and performance by separately elaborating a small changing portion from the once elaborated or a large fixed portion or design of the design and verification environment. So here what is main advantage is like when any small portion is changing means we can compile that small portion only, no need to compile the entire logic or total logic, no need to do that, only small portion is enough to compile or re-elaborate it again. So here is a pictorial representation of the test scenarios using a MSIE flow. You can see here this is called a first one or a primary snapshot, which is like without this is like a stable design, we can say. And if you are changing any portion, you have to compile it and elaborate it, and